Okay, right now we are in section 10.5, and I wanted to finish that up. We're looking at some applications of quadratic equations. Earlier in the last video, we looked at things like area of a rectangle, area of a triangle, okay, and so there's a couple of problems in the book where you'll be using the Pythagorean theorem, okay. So the Pythagorean theorem says that for any right triangle whose hypotenuse has length C and whose legs have lengths A and B, A squared plus B squared equals C squared. So the sum of the squares of the legs would be equal to the square of the hypotenuse. Now you can only use the Pythagorean theorem if you have a right triangle. Here's I've marked a right angle there, okay, a 90-degree angle. If you have any other triangle, not a right triangle, then the Pythagorean theorem would not apply. Okay. So let's take a look at some examples of where we're using the Pythagorean theorem. Problem 21. The two legs of a right triangle are 9 centimeters and 18 centimeters. Find the hypotenuse of the triangle. Round to the nearest tenth of a centimeter. Okay, so here I've drawn that triangle, and I got to find the hypotenuse, which I'm calling x. Well, the sum of the squares of the legs equals the square of the hypotenuse. Okay, or 9 squared plus 18 squared would be equal to x squared. And I got to solve for x. 9 squared is 81. 18 times 18 is 324. Okay, 324 plus 81 would be 405. So then I'd want to get, I'd take the square root of both sides in order to get x all alone. And of course I need the plus minus there. But here's the thing, since x represents the hypotenuse, or you're talking about distance, you're not going to have a negative in this. Okay, so like some of these other problems, you know, that come up with a negative number, just disregard that. You're talking about distance. Okay. I suppose in this problem, you know, if we had accidentally forgot about the plus minus, then that, you know, that'd be a rare time, I guess, where that's, you know, okay. All right, so then if you go to the calculator, the square root of 405, let's see here. So the square root of 405.0 is 20.1 is what I'm getting there. Okay, 20.1 roughly centimeters. Okay, here's another one. Problem 22. An airplane flies 700 miles north from city A and then turns 90 degrees and flies 2,400 miles east to city B. So I've got a picture there, flying 700 miles north and then going to turn it and make it a right angle and fly 2,400 miles east to city B. Okay, how far is it if the airplane flies directly from point A to point C? Okay, what would be this measurement here, which we'll call x miles? Well, so in this problem we have a right triangle, and I've got that marked with a right angle, so I can use the Pythagorean theorem. The sum of the squares of the legs equal the square of the hypotenuse. For us, that's going to be 700 squared plus 2400 squared equal x squared. 7 squared is 49, so 700 squared would be 490,000, right? You'd have 49 with 4 zeros after. Okay, and 2,400 squared should be 5,760,000, okay, if you were to check that. When you add these together, you should be getting 6,250,000, and you'll want to take the square root of both sides. You can disregard the plus minus since you're talking about distance. We know the distance can't be a negative for this problem here. And so then I'd go to the calculator. Okay, the square root of, let's see here, 6,250,000 is 2,500 miles. So that'd be if the plane were just to fly directly from city A to city B. Okay, problem 23 is the last one in this section. A 15-foot ladder is leaning against a wall. If the distance between the base of the ladder and the wall is 3 feet less than the height of the top of the ladder on the wall, how high up the wall does the ladder reach? Okay, so I've got a picture of what they're describing here. Here's the ground and here's a wall, and I've got a 15-foot ladder leaning against the wall. I'll call the distance from the ground to the top of the ladder x. That's what I'd like to know in this problem. How high up the wall does the ladder reach? It also says that the distance between the base of the ladder and right here at the base of the ladder and the wall is 3 feet less than the height of the top of the ladder on the wall. Okay, so whatever x is, this measurement here is going to be x minus 3. Now, you would assume in this problem that you've got a right triangle. Okay, like assume that the building is standing straight up vertically, it's not leaning, going to fall over, or something weird like that. Okay, so I have a right angle, creating this right triangle, and I want to find x. So I can use the Pythagorean theorem. The sum of the squares of the legs equal the square of the hypotenuse. As an equation would be x squared plus x minus 3 squared equal 15 squared. Okay, and so then I'd have to solve for x. Well, if you FOIL out x minus 3 times x minus 3, you would get x squared minus 6x plus 9. 15 squared is 225. So then I'm getting everything onto the left. Okay, combine these two terms. 9 minus 225 is negative 216. And I can make the numbers a bit nicer by dividing both sides by 2. Okay, divide the three terms here by 2. And so now I'm looking at x squared minus 3x minus 108 equals 0. This equation will factor nicely as x minus 12 times x plus 9. If you don't see that fairly quickly, be sure to use the quadratic formula. Okay, not everyone might see this, in just a few seconds, but of course there is that Plan B option. Okay, and it did factor nicely, and here it is. So then I set the factors equal to 0. You got x minus 12 equals 0 means that x is 12. X plus 9 equals 0 means that x is negative 9. X is the distance from the ground to the top of the ladder. That can't be a negative. Throw away the negative 9. And so that distance that we're talking about would be 12 feet then. Okay, so that is all for section 10.5. The homework problems in this section are on page 825.